Hey everybody. In class today we got some practice writing linear equations in slope-intercept form. Tonight we are going to get a little bit more practice with some more complex versions of those problems. So in order to solve these problems, we're still going to be using slope-intercept form. Remember, that's y equals mx plus b. But these problems might require us to do a couple more steps in order to find the right answer. Let's take a look at our first example, example A. So we have a line in example A. We have a linear equation. A line's going straight up from left to right. But we can't see our y-intercept here. So we know we could find our slope of this line, but we can't really see what the b is. What is the y-intercept? So in order to do that, we're going to have to use some algebra. So let's start by finding what we can find, finding the slope. So I know to go between these 2 points, I can find the rise and the run. My rise is going to be 1, 2, 3, 4, and my run is going to be 1. So my slope is 4 over 1, and we can simplify that to just 4. Now, because we don't know what the y-intercept is, we don't know what b is, but we can use this information that we have to find b. We know the slope, and we have 2 points, but we really only need 1 point. I'm going to pick 4, 1, just because both of those numbers are positive. I think it's going to make my life a little bit easier. Now, we can take the slope-intercept form of the equation, y equals mx plus b, and we can actually substitute in for 3 of these variables based on what we know. Now, we know what m is, right? We know m is 4. But from this point that we looked at earlier, we also have a value for y and x. This point gives us a y value of 1, and y equals 1 when x equals 4. And then we don't know b yet, but now we can use this information to find b. So if I simplify 4 times 4 over here, I get 1 equals 16. 16 plus b. And now I just solve this. This is a one-step equation. I subtract 16 from both sides, minus 16, and I get b equals negative 15. Now I can write my equation. Let's do this in a third color. We get y equals 4x minus 15. There's our equation. We now have our slope, and we found what our y-intercept is, negative 15. And if we look at our graph, the way this line is going, negative 15 for the y-intercept makes sense, right? That would be somewhere down here on the y-axis. Now, I chose 4, 1 because both of those values are positive. I also could have done 3, negative 3. Because these 2 points are on the same line, they have the same equation. If I would have substituted negative 3 for y and 3 for x, along with 4 for my slope, we would have gotten the same b, negative 15. So it doesn't matter what point you use as long as we do the steps right. So let's try another one here. We got a straight line in example B, but this time our y-intercept is between 0 and 1, and because it's not perfectly on the grid, we can't really know what it is. It could be 0.8, could be 0.9, could be 0.7. So we're going to need to use a little algebra here to figure that out. So first things first, let's find what we can find, which is the slope. Our rise is 2, and our run is 1, 2, 3, 4, 5. So our slope is 2 over 5. Now, remember, I can pick either of these points that I want. They're both going to have the same equation. I'm going to pick negative 2, 0, just because I like having a 0 to work with. I think that might save me some time. So we're still using slope-intercept form. Y equals mx plus b. We plug in my y value is 0. My m is 2 over 5. My x is negative 2 plus b. So now I need to simplify 0 equals 2/5 times negative 2. I can think of that as negative 2 over 1. It's going to give me negative 4 over 5 plus b. And now to solve for b, I just add 4 over 5 to both sides, plus 4 over 5. And see, that 0 came in handy because that's going to leave me with b equals 4 over 5. That's easy addition. So my equation is y equals 2 over 5x plus 4 over 5. And 4 over 5, if we were to write that as a decimal, is 0.8. So we're actually sort of close when we were looking at it earlier, but now we know for sure. In this example, we actually don't have a graph to look at to find the slope, but we can use our slope equation, m equals y2 minus y1 over x2 minus x1, to find the slope of the line that passes through these 2 points. Okay, so if we got our first point here, we got x and y, and we got our second point here, we have x and y. So to find our slope, we just got to use the numbers we have, -1 minus 5 and 2 minus -2. -1 minus 5 gives me -6. 2 minus -2 gives me 4. And I want to simplify this. That's going to be -3 over 2. So there's my slope. And now I just need to pick one of these 2 points to use. It doesn't matter which one I'm going to pick. I'm just going to pick this one because I like that my x is going to be positive. Probably doesn't matter. Definitely doesn't matter. It's going to give us our same answer. So let's go ahead and write out our equation now. We have y equals mx plus b. This is how the equation is going to look, and we just put our values in. Y, for the point we chose, is -1. Our slope is -3 over 2, and our x value for this point is 2 plus b. Now, -3 over 2 times 2 is just going to be -3. We still have our plus b here, and now we just solve. We add 3 to both sides. -3 plus 3 is 0, so that leaves us with b equals 2. So now we have our m, we have our b, and we just write our equation. Y equals -3 over 2x plus 2. And we're done with that one. When we're trying to write an equation in slope-intercept form, there's basically 3 different scenarios that we might come across. In the first one, we might know the slope and the y-intercept. That's really nice if we have that point 0, comma, b, because then we just plug the numbers right in. We put in m, we put in b, we have our equation. That's nice and easy. If we know the slope and one point that's not the y-intercept, then we got to do a little bit of substitution. We just take m, put that into the equation, put in the value for x and y from the point that we're given, and then we can find b. And once we find b, we write the equation. The one that requires the most work is when we have 2 points, but we don't know the slope or the y-intercept. And in that case, we got to use those 2 points to find the slope, and then once we know the slope, we pick one of the points and use that to find the y-intercept. So 3 different ways to do it, but it's all really covering the same concept. We're using the same skills, substitution and solving, to do all of it. Okay? Go ahead and submit your notes through Canvas. Have a good night. I will see you guys tomorrow.